Alright, welcome to 2.2, direct variation. Our essential question, how do you write and interpret variation equations? So direct variation is y equals kx. And k is a constant, okay, so it's just a number. And essentially you can think of it just like y equals mx plus b, except b is 0. And so we get rid of it, and then it's just kx. Now, why can't they just use m? I don't know, but we use k. So there we go. I don't like it either. So, but it's literally y equals mx plus b. It's just that b is 0 for this case, and so we have our constant of variation, which is essentially our slope, right? All right. So now if we going back, if we go to find sorry, I forgot, solve for k. If we want to find our constant of variation, all we need to do is divide by x, right? And we get k equals y over x. So if we ever want to solve for it, we just divide y divided by x. Okay, so for each function, determine whether y varies directly with x, and if so, what is the constant of variation? And so really, what we need to do here is we just need to do y divided by x and see if are we getting the same number each time. Okay, so our first case, we have 0.5 divided by 1, which is 0.5. Okay, then we have 1 divided by 2. Remember, we're doing y over x, so 1 divided by 2. And that's also, if we go decimal, that's 0.5. And then our last one, 1.5 divided by 3. And that is also, if you get your calculator out or whatever, also 0.5. And so it asks, if so, what is the constant of variation and the function rule? So it would just be, our constant of variation would be 1/2. And then our function rule would be y equals 1/2 x, or 0.5x. Okay. So same thing over here. We just start testing them out. Y divided by x. So 10 divided by 1 is 10. 22 divided by 2 is 11. Uh-oh. And so right here, these numbers aren't the same. And so this is not a direct variation. Okay, not a direct variation, because these two numbers are different. All of them have to result in the same number. All right, so for each function, determine whether y varies directly with x, and if so, what is the constant of variation and the function rule? Okay, so first off, we need to get y by itself, because that's our equation for direct variation, right? And so in order to get y by itself, we subtract 2. We get y equals x minus 4. Now, does that look like this? The answer is no, because it has this minus 4 sitting here. Okay, so this is not a direct variation. Okay, not a direct variation, because you have the extra, the plus b is there, right? We essentially need our b to be 0. Okay, so then we just leave it off. All right, so with this one, in order to get y by itself, we're going to multiply both sides by 6, and so we get y equals 6x. Is this a direct variation? Yes, it is. It is, because there's no plus b attached to it, right? And so what's our k? Our k is 6. And this is our function rule. Okay, so suppose y varies directly with x, and then we know that y equals -4 when x is 2. Okay, we need to figure out what is x when y is 10. Okay, so we can plug it into our equation to basically, we don't know what the constant of variation is. We don't know what k is, and so we do know y, and we do know x. So let's plug in y is -4. We don't know k, but we know that x is 2. So we can divide by 2, so we get k equals -2. Okay. Now that we know our constant, we can do y equals 2x. Okay, and then we can plug in the one that we know. We know y is 10, so 10 equals 2x, and we solve. Oh, I'm sorry, -2. -2x. Okay, so we divide by -2, and so we get x equals -5. Okay, now we could use a proportion instead, so let's try it out there. So when y is -4, x equals 2. You know, we have our y divided by 2 that we had right, not there. Not there either. Not there either. Here we go. Sorry about that. We had our y divided by x, right? That's how we found the k. That's how we found the constant of variation. Okay, so we could come back to me. Here we go. All right, right here. So y divided by x equals. Now we know our y is 10, but we don't know what our x is, and so you could also then you have to cross multiply. So we have -4x equals 20. We divide by -4, and we get x equals -5. Okay, either way, we're getting the same answer both ways. Whichever way you prefer is what works. I forgot to erase Levering's work here, so we'll just talk through it. Suppose that y varies directly with x. We know that if y equals 4, then x equals 2. We need to find x when y equals 6. So we could plug it in. Y equals 4, x equals 2. We solve for k. So we divide by 2, k equals 2. Okay, now we need to find what x is when y equals 6. Okay, so the red stuff. We know the constant is 2. We know y is 6, and so then we have to solve for x, and we get x equals 3. Another way you can do it is with this proportion. I love how she wrote it here. It makes it pretty clear. So we know y is 4. We know x is 2. Okay, and then the red ones, we know that y is 6, and we don't know x. We cross multiply, so you get 4 times x equals 12. In order to get x by itself, you divide by 4, and again, x equals 3, just like it did over here. So, two different ways. The cost of buying Flamin' Hot Cheetos varies directly with the weight. If an 8.5 kilogram of Cheetos cost $47.60, that's a lot of Cheetos. How much do 20 kilograms cost? I don't know why you'd ever need 20 kilograms of hot Cheetos, but here we go. So we can plug it in, right? So when we have 8.5 times the constant, that gets us our total amount, right? So we could do 4760 equals, we don't know our constant yet, but we do know 8.5, right? So here's our kind of our blue numbers, and then we're going to try to figure out how much 20 kilograms costs. Okay. So then we divide by 8.5. We get k equals, our constant equals 5.6. So then we plug it in. Y equals 5.6x. Okay. Now for our second problem, how much does 20 kilograms cost? So we have 20 that we can plug in here. So y equals 5.6 times 20 kilograms. It's like 40 some pounds. And when we do the math on that one, we get $112. So if you ever have $112 to blow on Flamin' Hot Cheetos, enjoy that. Doing it with a proportion here, we have 4760. Whoops, 4760 divided by 8.5, y divided by x. Okay, and then over here we have 20. Nope, sorry. We have y over 20. A little bit different than the last problem, wasn't it? Okay. So we cross multiply. We get 8.5y equals 952. We divide by 8.5, and we get that y equals 112. All right, last one here. A dripping faucet wastes a cup of water if it drips for 3 minutes. The amount of water wasted varies directly with the amount of time the faucet drips. Okay, so obviously it's all kind of proportional. The more time it drips, the more water you waste, right? How long will it take for the faucet to waste 4.5 cups of water? Okay, so our first numbers here, a cup of water for every 3 minutes. Okay, so we get 1 cup wasted every 3 minutes. Okay, so our K would be, when we divide, our K would be 1/3. Okay, and so now it wants to know how much will it take to waste 4.5 cups. And this is your Y. Okay, so 4.5 cups, 1/3 X. There we go. And then in order to get rid of the fraction, we need to multiply both sides by 3. And we're left with X over here. Multiply both sides by 3. And 4.5 times 3 is 13.5 minutes. Not very long time to waste 4 cups of water. Okay, now if we do it in proportions, our first one, we have 1 cup of water every 3 minutes. So how many, 4.5 cups of water in how many minutes? When we cross multiply, we get 1x over here, and 3 times 4.5 is 13.5. So as you can see, you can use proportions, or you can use, plugging it in and solving for k, and then plugging your unknown variable back in or whatever. You could also use proportions, whichever one you're most comfortable with. I tend to prefer the one on the left. Sometimes the one on the left takes longer than the one on the right. It's up to you. So that's section 2 of chapter 2. If you have any questions, let me know.